So Chebyshev's inequality says that this statement will be true for any distribution we have. And it will tell us the percentage of data that lies within a certain number of standard deviations of the mean. So what that means, let's look at a picture to make more sense of that. Imagine this red line is the distribution of people's weights with the mean 150 pretty close to the middle. So there's going to be people who weigh less and there's going to be people who weigh more. And I'll say the standard deviation is 10. And I tried to space these blue bars out evenly. But Chebyshev's inequality will say, well, let us figure out what percentage of people lie within one standard deviation of the mean. So either in between one below and one above. So you can use Chebyshev's inequality to say how many people lie within one standard deviation. So anywhere in that range. With this data, that'd be between 140 and 160 because the standard deviation is 10. And what percentage lies in between there? You use this inequality, 1 minus 1 over 1 squared. So it would be 1 minus 1 over 1 squared is 1. So we actually get the answer 0 because Chebyshev's inequality has to work for any distribution. It gives us a very a safe answer back that's going to be true for any distribution. So within one standard deviation, there's going to be, from his inequality, 0% of the data. Let's take it a step further though. How many people lie within two standard deviations? So again, with our numbers, that means they're within 140, 130. So that's two standard deviations below, or two standard deviations above would be 160, 170. What percentage of people lie within two standard deviations? 1 over 1 minus 2 squared, which would be 4. So now we get 75%. So for any distribution, no matter what it is, if you know the mean and the standard deviation, you can claim that 75% of the data will be within two standard deviations of the mean. So let's come back to look at our problem. A says, what minimum percentage of gasoline stations had prices within 3 standard deviations of the mean? So 3 steps above or 3 steps below. We'll use the inequality 1 over 1 minus, it'll be 9. 3 squared is 9. We'll come out to 0.888 going on forever, and you round that, then you'll get 88.9%. So 88.9%. For sure, 88.9% lie within 3 standard deviations. That's the minimum possible percentage. It could be a lot more than that, but at least 88.9. That's what this theorem is telling us, is the absolute lowest amount that could lie within that range. That's why you get 0 when you do the first one, because 0 is the absolute lowest amount that could lie within that range. Could be a lot more. Definitely couldn't be less. And then within 2 standard deviations, 75% lie within that range. Could be a lot more within that range, depending on your data, but it can't be less than that. And what we just solved in part A is that within 3 standard deviations, so for this example between 120 and 180, we just solved that the minimum that can be in that range is 88.9%. Could be a lot more, but it can't be less than 88.9%. For B, looking at the minimum percentage, what minimum percentage of gas stations were within 2.5 standard deviations? Plug a 2.5 in, and so you get that a minimum of 84% had to be within 2.5 standard deviations of the mean. Either 2.5 above or 2.5 below, they're within that range. So what is 2.5 above or 2.5 below? Well, calculate the mean, it's given to us, and then 2.5 of the standard deviation. So that, if you work that out, you get up to $3.21, and then 2.5 standard deviations below gives you $2.91. So 84% of gas stations are in that price range. A minimum of 84. It could be a lot more, but from Chebyshev's inequality, we just know it's at least 84% in that price range. And for part C, the minimum percentage of gas stations that are in between this price range, you have to figure out in terms of standard deviation, how many standard deviations below the mean and above the mean are we talking about? So let me scroll up here. The mean was $3.06. So 2.94, how far away is that from the mean? It's 12 cents below. And the standard deviation is 6 cents. So it takes 2 standard deviations below to get to 12 cents below. So this price is 2 standard deviations below. And $3.18 is likewise 2 standard deviations above, because it's 12 cents more than the mean. Standard deviation is 6 cents, so that's 2 standard deviations above. So C is asking what minimum percentage is within 2 standard deviations, either above or below. So if you plug a 2 into Chebyshev's inequality, you get 0.75 or 75%. So the minimum amount of gas stations in that price range is 75%.